Okay, so who knows what an absolute value is? Discuss with your neighbor, what is an absolute value? Go ahead. A value that's absolute. That's a great answer. That's not what we're looking for, though. I love how people, I heard it from a couple people talk about distance. And it's the distance a value is from 0, where distance is always positive. You okay, Mr. Blazinski? Nah. Now, if I take the number 3 and I use lines around it, these lines designate an absolute value. Oh, I'm sorry. We can think about 3 on a number line and its distance away from 0. How far away is 3 from 0? 3. So the absolute value of 3 is 3. I know, it's perfect. It's great. Who's giving you a hard time? Don't give them a hard time. If I took -3 and I put these straight lines around it, this is the notation for find the absolute value of this. Did you get it? And we look on a number line. What is the distance the value -3 is from 0? If we think of distance as being positive. 3. Okay? So what absolute values do, essentially, to make it easier, instead of having distance, is if you have a positive value, it's going to stay positive. But if you have a negative value, it's going to become positive. Okay? So, we will be solving for the rest of this class period absolute value equations. Like the absolute value of x is equal to 5. Please discuss with your neighbors what x equals. Okay. So, we automatically go and say, oh, 5, right? 5 is a distance of 5 away from 0, but we also have -5. So it turns out, when we're solving an equation, what we're looking for is the positive or negative value for x that gives us 5. And what I can do with that plus or minus is actually move it over here to the right side. And this is the key, is that we are looking for both a positive value and a negative value to solve an absolute value equation. Now, absolute value x plus 2, if I were to solve that. Discuss with your neighbors what you think you should do. Well, we can just kind of stop here and say, what does that have to be when added to 2 gives me 7? Whatever that absolute value of x has to be, it has to be 5. So that means I have 5 and -5. We can go straight to our answer there. Or we know that with equations, we can help simplify and isolate some things. And I can isolate the absolute value by subtracting 2 from both sides, or adding -2. I'm not going to show that step. You guys are in college algebra. Okay? Then we say, since this absolute value is equal to 5, x could have been the positive or the -5. And we can stop right there. For the rest of these two examples, it's the same thing. Our goal is to isolate the absolute value of x, and then once we have the absolute value x solved for, set equal to a number, know that it's going to be either the positive number or the negative number that we could have for x. So why don't we solve the one on the left? Unbelievable. It's like every single one of these problems is going to end up with the same answer. Is that going to be the case? So using your instincts, you guys should know, hey, I could divide everything by 3 or multiply everything by 1/3, but I don't want to. Instead, I can subtract 2 from both sides. So everybody subtract 2 from both sides. After I subtract 2 from both sides, I'll have 3 times the absolute value of x is equal to 15. I then divide by 3. Just give me the A. Just give me the first one if that happens again. Okay? And then if I divide by 3 on both sides, I can isolate the absolute value. The absolute value of x is equal to 5. What values have a distance that is equal to 5? Well, we can say that's just the positive and the negative 5. Now for the next one, I put this absolute value in the denominator for a reason. And a lot of students are thinking, oh man, let me get rid of that 2. So I'm going to multiply by 1/2 or divide by 2. That will work. But discuss with your neighbors, can I write the absolute value of x minus 3 equals 2? Is that correct?
No.
Discuss with your neighbors, not with the class. Thank you. Mr. Moore can tell you. So we have to be careful. This is not right. Yeah, I'm telling you this is not right, and you're going to discuss with your neighbors why it's not right. Doesn't the 2 cancel out? Don't I just have absolute x minus 3? What's the problem?
Well, it's over negative 3. It's not like being subtracted by negative 3. So it should be. You should multiply by negative 3 on both sides.
No,
No?
shouldn't do that.
Can you multiply by the
What do you think, Miss Robeson? You don't know?
Can you multiply by the absolute value?
Listen, I can do this. I can multiply both sides by 1/2, but I'm not going to get the absolute value of x minus 3 equals 2. This is wrong. But if I did something to this, if I change this, okay, I can make it right. What can I do to make this correct? If I take this fraction and multiply it by 1/2, the 2's cancel, right? But why? Because it's 2 divided by 2. Well, what's 2 divided by 2? 1. Okay, now usually when we have a 1, we can just like disregard it because it's gone. But in this case, 2 divided by 2 is 1. I have a 1 up there. Okay, so we have to be careful. This is fine. We can do this. But we don't get straight to absolute value of x minus 3 equals 2. Okay?
Multiply by the absolute value of x minus 3 on both sides.
Yes, that is a good idea, and we could have done that to start, but we can do that now as well. If you multiply by the quantity of your denominator, then this will cancel here, and I'll leave myself with 1 is equal to 2 times the quantity of absolute value x minus 3. Going back to the first step, could you have multiplied both sides by the absolute value of x minus 3? Yes. What also could you have done instead of doing that? Any other ideas of what I could have done to get this x minus 3 in a numerator?
Times negative 3 over 2.
Nope, that's not going to help me. I did this in another lesson. This is like new to you guys. You're like, whoa. This Blaylock, do you remember? You could flip both sides, okay? It is totally legal in equations and solving equations that if I have two fractions, and we can always have two fractions, but if you flip both sides, it's like taking 1 divided by both sides. Well, as long as we do the same thing to both sides, we're going to be fine. So I could have flipped both sides from the beginning and then had that absolute value of x minus 3 in the numerator equal to 1/4. Okay, let's just go ahead and solve that both of these equations and get to the answer. So if I have this or this, well, this guy, I would multiply both sides by what? 4 or 2? 2. Okay, good. So let's go ahead and do that. My thing just went out. Get absolute value of x minus 3 is equal to 1/2, which is 2/4. Over here, this guy, what instincts are telling us? What should we do here? 2 times absolute value of x minus 3. Mr. Manley, what are you doing with your finger?
I forgot what it's called.
Distribute. Thank you, Mr. MacArthur. So I can distribute this too. Totally legal. Okay? Now, no matter which way we do things, whether we get it the first way or the second way, we're going to get the same answer. Okay? I'm going to add 3 to get the absolute value of x by itself. 3 plus 1/2, that's 6/2 plus 1/2, that's 7/2. Here I would add 6 to both sides. I get 7 is equal to 2 absolute x. Divide by 2, absolute x is equal to 7/2. That's not my answer though. What is my answers for x? Plus or minus 7/2. Okay, so multiple approaches. This approach, flip both sides. This approach, multiply both sides by the quantity absolute x minus 3. Both work. Okay? Now let's see this next situation. I got absolute x minus 1 equals 4, and I got the absolute of x minus 1 is equal to 4. Will I get the same solutions? Well, go ahead and solve this one for me first. Get my answers. Check with your neighbor. Good. We add 1 to both sides. We do not have to show that. We're in college algebra. And then we know that x could be either the positive or the negative 5. Okay. Now, Mr. Moore, if I plugged in positive 5 into that guy, is that a correct answer for the second guy? If I plug in positive 5.
Yes.
Good. 5 minus 1 is 4. Absolute value is 4. Good. But, Mr. Mora, if I plugged in negative 5 into that, am I going to get a balanced equation 4 equals 4?
No.
What do I get if I plug in negative 5?
Negative 6 equals 4.
Right. It would be the absolute value of negative 6, which equals 4. So actually, these are going to have different answers. Okay? Well, we know that what is inside of this can be what? A positive 4 or a negative 4. Whatever is inside of the absolute value has to equal plus or minus 4. So what I actually can do is say, all right, well, whatever is inside of my absolute value has to equal plus or minus 4. Which means I now have 2 equations to solve. And here is, our next type of problem. If I have things other than just x and an absolute value. When I have things other than just x and an absolute value, we may have to solve two equations. First, the x minus 1 equals 4, and the other one is the x minus 1 has to equal negative 4. We're going to add 1 to both, but we can see that we do not get 5 and negative 5. In this case, we got 5 and negative 3. Okay? Let's see if you can solve both of these equations. And understand and notice when you solve both of these equations that your solutions are going to be different. And you're going to have multiple solutions, not just one. Because I know whatever's inside this absolute value on the right could either be positive 7 or negative 7. Because the distance is going to be a total of 7. So if we're just getting one solution, we're not thinking about the other possibility. We're over here. You skipped ahead. Well, how is Mr. Pottorff going to check his answer? So tell him the answer and he can check with you. No, Mr. Moore is going to tell him his answer. Okay, that's the one on the left. What about the one on the right? Divide by 2. Divide by 2. You just told me that it's not plus or minus 5 for the previous one, and then you're telling me this one's plus or minus 3? What happened, Mr. Genius? This is being recorded, by the way. I will always call on people who are not following along with the notes and doing what they're told on. And it will be on YouTube for forever. Do you realize that when I post videos on YouTube, I put them public settings, and I never delete them? So literally, we could search this video 50 years from now, and we can find me yelling at you, okay? Yes, it will be. Guaranteed. We'll be able to speak into our computer and say find that video with Mr. Messner and Mr. Moore getting yelled at, and boom, it's gonna pop up like that. Yes, of course, all of it.
What do I do now?
You're done. You have x equals plus or minus 3.
Why is there 2 on this one and not 2 on this one?
There is positive 3 and negative 3. There's 2 answers. The last step is to get rid of those absolute values. All right. So for the one on the left, I subtract 1. I then divide by 2. Now here, a lot of people are stopping here and saying absolute x equals plus or minus 3. This is a key step. Whenever you have an absolute value isolated, you can get rid of the absolute value so long as we understand that our answer inside the absolute value could either be the positive or the negative value that we're looking for. Okay? So notice this goes here. But we know that when I get rid of the absolute value, I could either have the positive or negative 7, right? Whatever's inside that absolute value could be 7, absolute value of 7 is 7, or negative 7. The absolute value of negative 7 is 7, which means I have 2 equations to solve over here on this right one. 2x plus 1 equals positive 7, and 2x plus 1 equals negative 7. I add 1, I divide by 2, I get x could equal 4. Add 1, divide by 2, I get x could equal negative 3. So is it plus or minus 3? No. It's 4 and negative 3. Sorry, 6. I was so just into this that I don't think. I've done that a lot in this class. There we go. Are they plus or minus 3? No. Okay. So here's the key to solving absolute value equations with more than just x in the absolute. Okay? Isolate your absolute value. Then get rid of the absolute value by setting your stuff inside your absolute value equal to plus or minus the number on the other side. Then solve your two equations. A positive equation and a negative equation. So here, my absolute value is not isolated. I would have to start by subtracting 3. Everybody subtract 3. Now that my absolute value is isolated, I can get rid of it because I know I can have a positive or negative 9 inside my absolute value. And that would give me the correct answer. From that, I developed two equations. One where I have the 2x minus 1, the stuff inside, equal to the positive 9, and the other one where 2x minus 1 is equal to the negative 9. Add 1, divide by 2. Okay? Please do z next 2. We should be getting 2 solutions for all of these because I could have positive 8 or negative 8 inside the absolute value, and I'd get that the absolute value of that is 8. Go. Is the absolute value isolated?
No.
It is. You've gotten rid of the absolute value, but when you get rid of the absolute value, what do you have to do over here?
Make it negative.
It could be positive or negative.
This is my first equation.
Why?
And then I'm going to do negative 1.
Okay. All right, good. Okay, check your answers with a neighbor. Just leave it as a fraction. So protocol is to put them from least to greatest, but I don't care. As long as you get both correct solutions. Don't forget to divide by negative 3. And 8 plus negative 5, negative 13. Okay? I'm not going to simplify 13/3. I can't. I don't care if it's a decimal or not. It's a repeating decimal, so I'd rather have it as a fraction, because that's an exact answer. Do the one on the right. Yeah, you can leave them as a fraction. I'd actually prefer fractions over decimals if it's a repeating decimal. Stay focused. We should power through these. We know how to solve equations. The key to these is just understanding that we have 2 equations to solve. Okay, I should get negative 1 and 13/3. Then I should get 3 and negative 3/2 or negative 6/4, which is 1.5. Any questions on these? Just make sure you keep track of your signs. Make sure things don't disappear on you like a negative inside the absolute value, and we'd be okay. Okay? Now, the next two, there's just one extra step. Make sure you isolate things first. For the previous one, you didn't have negative 4.
Yeah, I know.
You had just positive 4.
Wait, you go to the one you just.
Yeah. The answers.
Yeah. The one on the left.
Yep.
Keep going.
So this negative disappeared on you as well.
Yeah, so absolutely.
No. You have to think about whatever is inside the absolute value. Could either be the positive value on the other side of the equation or the negative value on the other side of the equation. I'm not absolute valuing what's inside here. I'm saying the stuff inside there could either be positive 8 or negative 8. So this stays as a negative. Okay? So this is a mistake that some students make. They think, oh, I absolute value things. I get a positive 4y. I absolute value, I should get a positive 3x. No, it's whatever is inside your absolute value. That has to be positive or negative 9, which means keep the negative here. Keep the negative here. If it was minus 5, keep the minus 5, okay? Yeah, you can leave it as that. Yeah, that's fine. The decimal. If it's not a repeating decimal, then it's fine. The only thing different about these guys, we have to isolate our variable, our absolute value first, not our variable. What's up? Good question. What happens if we get 0? Why don't we change the last one so we get 0? I'd get 2x plus 3 is equal to positive 8, or 2x plus 3 could equal negative 8. Subtract 3, x is equal to 2.5. That stops, so I can just use that. Subtract 3, divide by 2, x is equal to negative 5.5. That stops, so I can use the decimal there. Okay. Now change this to a 3 instead of a 5, please. I'm sorry if you already did it. Do it again.
This equals 1 to a half equals 0. That's what I said.
Oh, that's fine. But let's do this one.
Yeah, I got the same answer twice.
Because you said positive 2 and positive 2. I need a negative 2 there. We need a positive 2 or a negative 2.
Oh, why did I do that?
Okay. So I add 3 to both sides. I get absolute 3y plus 1 equals 0. Is there a difference between a positive 0 and a negative 0? 0 doesn't have any sign. So really, if we have this situation, there's only one answer. I need a value that has a distance of 0 away from 0. That's just going to be 0. So I don't need 2 equations. If you set up 2 equations, you'd get the same answer for both. And that's not what I want. Okay? So there's no such thing as positive 0, negative 0. It's still 0. Okay. Let's power through the next couple. Why don't we just do one of each? Maybe the top right one and the bottom left one. Because we got to get to another situation. One more situation.
Wait, should I distribute that?
So, can I distribute a number inside an absolute value? No, don't do it, okay? Just isolate your absolute value. Think of this as a big ol' X. 3x plus 4 equals 16. Don't distribute, just get rid of everything else except for the absolute value. This is a key thing to remember. Okay, don't distribute over absolute values. Isolate the absolute value. Then set up your equations to solve. This guy down here, so I got 8 and 0 for those guys. This guy down here, it's just a fraction, but the x is in the numerator. So it should be easy to work with. I can just get rid of the 4 by multiplying both sides by 4. Make sure I don't change anything in the absolute value. Just set up your two equations and solve. Okay? Just solving equations. All right. For the last two, we should have gotten x equals 3 and negative 7/3. Multiply both sides by 4, add 1, divide by 3. All right, discuss with your neighbors. What is our solution for x in this situation?
Two negatives.
Is it plus or minus 2? No, because the absolute value of 2 is positive 2. The absolute value of negative 2 is positive 2. So nope, that's not right. Miss Thornock, what do you think? You are correct. Absolute value is always positive. We're always talking about a distance away from 0. We can never have a negative distance. So in this situation, we need to recognize that there are no solutions for x. If I tried to solve the next one, and this is where students get caught up, they subtract 7. They're all into things. They get 2x plus 5 equals negative 4. And then they're like, all right, 2x plus 5 equals plus or minus 4. And then they go and solve those two equations, but all of their work is pointless and unnecessary because an absolute value can never be a negative number. An absolute value is a positive distance from 0. Absolute values are always positive. So whenever I see an absolute value equal to a number, no matter what it is, you can't have a solution. Now, what if I have an absolute value on both sides of an equation? Well, originally we could say get rid of the absolute value, make the other side plus or minus. Well, if I get rid of the absolute value here and make the other side plus or minus, I'd have to get rid of the absolute value here and make the other side plus or minus, which means I have a plus or minus on both sides of the equation.
Minus, minus, plus, plus, minus, plus.
Yes, this is brilliant. We have 4 different situations, it appears like, because we have plus or minus, which means like, okay, I have a plus and a plus. What's that going to look like? 3x minus 1 equals x plus 5. And then I have a minus, minus. Wait, hold on a second. Plus, plus, minus, minus. Couldn't I just divide both sides of this equation by -1? And if I divided both sides of this equation by -1, since this is in parentheses, what happens? This is the same as that guy. Oh, so I actually have two of my situations are the same. And then I also have a plus and a minus. And a minus and a plus. So I got all the four situations with this plus or minus. However, can I just multiply this guy by -1 and it turns into this guy? Turns out these situations are the same and these situations are the same, which means there are only two of the four possibilities that we have to worry about. When you have absolute values on both sides of an equation, we need to worry about setting the two sides equal to each other as positives, and then setting the two sides equal to each other with one being positive and one being negative. Now, it's very important before you put away your stuff and you think, oh, I got this, because like this is different, this is new. The negative must get distributed. You need to solve two equations, just like we were doing. You will get two different solutions. And we will practice that, of course, before our next quiz, but the rest of the examples will be on this video. So, absolute values on both sides of the equation, two situations. They both have the same sign, or they both have opposite signs. Now, I could have the opposite on either side, as long as I have it on one of the sides. Here I have them being both positive. Here, one is negative, one is positive. I can add 2y, subtract 3. I get 6y is equal to 0, which means y equals 0. I would rewrite this as -3 plus 2y equals 4y plus 3. Subtract 2y, add 3. I get, subtract 2y, subtract 3. I get 2y is equal to -6. Y is equal to -3. So 0 and -3. Last one. Two situations, absolute values on both sides. The both equations have the same sign. Or the equations have opposite signs. Doesn't matter which side you put the negative on, as long as you put it on one of the sides.
Hello, Mr. Mesner.
How are you?
Pretty good. How are you?
Good.
Wait, is this him talking to yourself or are you talking to us?
Talking in my video.
Oh.
Video.
Now, in this situation, since I have this, it looks like I only have one solution. I'm going to just check by taking the opposite of both sides.
You didn't know that?
All right, so in this situation, the equations can't be opposites of each other. We only have one solution. So it seems like no solutions, but I already have one solution. So check both. Maybe you only have one solution. That is it.